What is dark matter? Dark matter is a hypothetical stuff that makes it possible for galaxies to exist. The gravity of visible matter is not strong enough to build galaxies or complex structures, so the stars would be more likely to be scattered all over the place instead of forming galaxies. Because of this, we know that there is something inside them and all around them holding them together. This something doesn't produce visible amounts of light. In fact, it doesn't interact with light at all. In 1933, Fritz Zwicky measured the motions in the Coma cluster, a large cluster of galaxies that contains over 1,000 identified galaxies, and got an estimate on how much mass there was in that cluster. He then compared it to how much mass he could actually see looking at the galaxies. He noticed that the galaxies were moving too fast within the cluster for the amount of illuminated stuff he could see. By his calculations, there should have been 160 times more illuminated mass for the random speeds of the galaxies in the cluster. Something else was affecting their motions. Zwicky concluded that the cluster could not be stable unless there was a large amount of dark matter present. We know more about what dark matter is not than what it is. In fact, there are only 3 things that scientists do know about it. 1. Something is out there. 2. It interacts with gravity. 3. There is a lot of it. There are speculations that dark matter is made up of complicated particles that doesn't interact with light and matter the way we would think, but right now scientists don't really know, and observing something you can't see isn't easy. The first to propose dark matter based upon strong evidence was Vera Rubin in the 1960s and 70s, using galaxy rotation curves. Like Zwicky, her observations also seemed strange. What she actually measured was that the galaxies moved further and further away, the velocity of the orbiting gas and dust remained constant. The outer parts of the galaxy were rotating fast enough that there must be a lot more mass, or otherwise the galaxy would have flown apart. Dark matter was present in the galaxies and had enough mass to keep the rotation speed constant. Rubin estimated that there was 10 times more dark matter than ordinary illuminated matter. So how do we know it really exists? How can we find something that's invisible in space? Dark matter has finally exposed itself by bending light as it passes through it. It's called gravitational lensing. It deflects the light ray or bends it in its path. By tracing the light's path, gravitational lensing detected dark matter concentrated in the halos of galaxies. Gravitational lensing proved to be reliable, and dark matter's presence was suddenly revealed. Gravitational lensing is so precise, scientists can actually pinpoint not only how much dark matter there is, but how it's distributed in its position in the sky, because scientists can measure the distortion of light passing through the dark matter. To find out what dark matter was made of, scientists began to look at the things that didn't emit light. Black holes, MACHOs, brown dwarfs, all disregarded as possibilities. Atoms, protons, and neutrons were also disregarded. There cannot possibly be enough to account for the total amount of mass seen in the galaxies and clusters. Other possibilities were neutrinos, which is a high-energy particle and, like dark matter, passes through the Earth 1,000,000 particles at a time, but they are too light to have the effect that dark matter has on gravity. Axions are another possibility. They are very light and believed to be created at the moment of the Big Bang, just like dark matter. Theory has it that they can change to protons while dark matter is stable. After exhausting all possible candidates, scientists believe that dark matter is a new and mysterious particle unlike anything on Earth. The most popular idea on what dark matter could be is called a WIMP, weakly interacting massive particles. They have not yet been detected, but they are a perfect candidate. Finding dark matter will not only give proof of its existence, but might also answer the other big question of space. Besides giving the universe structure, dark matter may play a role in its fate. The universe is expanding, but will it expand forever?